This video is about solving problems involving collected particles by either considering the particles separately or if they are moving in the same straight line as a single particle. So let's go through some examples. Two particles P and Q of masses 5 kg and 3 kg respectively are connected by a light inextensible string. Particle P is pulled by a horizontal force of magnitude 14 newtons along a rough horizontal plane. Particle P experiences a frictional force of 10 newtons and particle Q experiences a frictional force of 6 newtons. So we've got particle P, which is being pushed forward by 40 newtons. It is on a rough horizontal plane. We've got particle Q is connected by a light inextensible string, which means each particle feels tension. Okay, and we know P is of weight 5 kg, so the weight is 5g. Q has mass 3 kg, so has weight 3g. There's a resistance on particle P of 10 newtons, so 10 newtons this way, and particle Q is 6 newtons, so 6. Acceleration is this way because horizontal force of magnitude 40 newtons are being applied on that direction. So it says find the acceleration of the particles. So what I would do is I would do Newton's second law, apply Newton's second law horizontally for the whole system. Because it's moving to the right, forces acting to the right, which is 40 plus T, and then I have to subtract all the forces acting on the left, which is minus 10 minus T minus 6 must be equal to mass, which is total mass is 8 kg, so 8 times acceleration, which is 8a. So if I look at the T and the T cancels out, 40 take away 10 take away 6 is 24. So 24 is equal to 8a. So a will be equal to 24 divided by 8, which is equal to 3 meters per second squared. So that's the acceleration. Find the tension in the string. So that means find T. Now we have two obviously things that we can work with, either isolate P or isolate Q. So we're going to do Newton's second law horizontally for Q. That means forces acting to the right, which is T, minus forces acting to the left of Q is 6, must be equal to mass, which is 3, times acceleration, which is 3. So that means T minus 6 must be equal to 9, so T must be equal to 9 plus 6, which is 15 newtons. So tension is 15 newtons. Explain how the modeling assumption that the string is light and inextensible has been used. So inextensible means acceleration of objects are the same. Light means tension is the same throughout the length of the string. And also that the mass of the string is negligible. Okay, next question. Particles P and Q of masses 2m and 3m are attached to the ends of a light inextensible string. The string passes over a small, smooth, fixed pulley and the masses hang with the string taut. The system is released from rest. So that means if I were to draw it out, we've got a pulley. And then we've got strings on either side. We've got particle P and particle Q, which is heavier, so that means it's going to be lower. So particle Q is heavier. And particle P has mass 2m, so weight is 2mg. Particle Q, the weight is 3mg. Each string feels also, P and Q also feel tension of the string. tension, the pulley feels the tension as well. And so there is some force that is holding up the pulley. Okay, because Q is heavier, I'll be accelerating this way for Q and accelerating that way for P. A, find the acceleration of each mass. So if we apply Newton's second law, because there's too many unknowns, we've got M, which is an unknown, we've got A, which is an unknown, we'll have to set up simultaneous equations. So Newton's second law applied vertically for P. Because it's moving up, it'll be T minus 2mg. T is the forces acting up. Take away the forces acting down must be equal to mass, which is 2m times acceleration. Okay, similarly, if I apply Newton's second law vertically for Q, then because it's traveling down, 3mg minus the tension must be equal to mass, which is 3m times acceleration. So I've got one equation and equation 2. If I do 1 add 2, then I eliminate the t, and all I'm left with is 3mg take away 2mg, which is just mg, must be equal to 2ma plus 3ma, which is equal to 5ma. So I can cross out the m's, because m is non-zero. So a will be equal to 1/5 g meters per second squared. Comment on any modeling assumptions. So the modeling assumption is because it's a light string. Comment on any. So let's just say tension. Because it's a light string, tension is the same on either side. Because it's a light pulley. On either side of the pulley. Therefore, tension acting on P is equal to tension acting on Q. C, find the tension in the string. So again, we can either use equation 1 or equation 2. So we're going to say using, let's say 1, which is Newton's second law applied to P. T minus 2mg must be equal to 2m times acceleration, which is 1/5 g. So T would be equal to 2/5 mg plus 2mg, which means T is equal to 12/5 mg newtons. Find the force exerted on the pulley by the string. So that means we're trying to find F. Because the pulley is stationary, it's not moving, it implies that F, forces acting up, which is F, must be equal to forces acting down, which is T plus T, which is 2T, which implies F must be equal to 2 times 12/5 mg, which is equal to 24/5 mg newtons. E, find the distance moved by Q in the first 4 seconds, assuming P does not reach the pulley. So that means we have to set up a SUVAT. We're trying to find the distance, so that is question mark. Initial is released from rest, so 0. Final speed, we don't know. Acceleration is 1/5 g. And time is first 4 seconds, so 4. So what we have in front of us is S, U, A, and T. So that means S is equal to UT plus half AT squared. So S is equal to 0 times 4 plus half times 1/5 g times 4 squared, which means S is equal to 15.68, which means S, because we round to 1 decimal place, is 15.7 meters. A lorry of mass m kg is towing a trailer of mass 3 m kg. So we have a lorry and a trailer along a straight horizontal road. The lorry and the trailer are connected by a light inextensible tow bar, so it feels tension. Okay, the lorry exerts a driving force of 50,000 newtons. So driving forward by 50,000, causing the lorry and trailer to accelerate at 5 meters per second. So acceleration is 5. The lorry and the trailer experience a resistance of 4,000 newtons. So the lorry is 4,000 and the trailer 10,000 newtons. So respectively means in all that order. Okay, find the mass of the lorry and hence the mass of the trailer. So if I want to find the mass, which we don't know, then we need to apply, oh, we do know the mass actually. So this is M. If the mass is m kg, then lorry has weight mg. And if the mass is 3 m kg, then the weight of the trailer is 3 mg. Okay, A. Let's apply Newton's second law to the whole system. Then 50,000 plus T, take away T, take away 4,000, take away 10,000, must be equal to mass, which is equal to 3m plus m times acceleration, which is 5. Okay, which means that the T's cancel out. 50,000 take away 10,000, 46,000, 40,000, so 36,000 overall. So 36,000 must be equal to 3m plus m is 4m. 4m times 5 is 20m. Therefore, m must be equal to 36,000 divided by 20, which means m is equal to 1,800 kg. Therefore, mass of lorry is equal to 1,800 kg and mass of trailer is equal to 1,800 times 3, which is equal to 5,400 kg. Find the tension in the tow bar. So let's try Newton's second law on either. So horizontally, let's do it for trailer. Then we know T minus 10,000 must be equal to the mass of the trailer, which is 5,400, times by acceleration, which is 5. So tension will be equal to 5,400 times 5 plus 10,000. Tension works out to be 37,000 newtons. Part C, explain how the modeling assumptions that the tow bar is light and inextensible affect your calculations. So light means tension is the same throughout the length of the tow bar. Also that the mass of the tow bar is negligible. Inextensible means acceleration of lorry and trailer is the same. Two particles A and B of masses 10 kg and 5 kg respectively are connected by a light inextensible string. Particle P hangs directly below particle A. So got particle B and particle A. A force of 180 newtons applied vertically upwards, causing the particles to accelerate. So it's going to accelerate up. The force of 180 acting upwards. A feels tension plus its own weight, which is 10g. B also feels tension pulling it up, but it also feels its own weight pulling it down, which is 5g. Okay, A, find the magnitude of the acceleration. So Newton's second law applied vertically to whole system. Forces acting up is 180 plus t minus forces acting down, which is minus t minus 10g minus 5g, must be equal to mass, which is 15 times the acceleration. So the t's cancel out. You get 180 minus 15g is equal to 15 times acceleration. So acceleration will be 180 minus 15g divided by 15. You put that into your calculator with g is equal to 9.8. Acceleration turns out to be 2.2 meters per second squared. B, find the tension in the string. So it's easier to do Newton's second law vertically on B. Then we get T minus 5g must be equal to mass, which is 5 times acceleration, which is 2.2. So T will be equal to 5 times 2.2 plus 5g, which means T is equal to 60 newtons. Figure 3 shows a system in equilibrium. The rod is firmly attached to the floor and also to an object P. The light string is attached to P and passes over a smooth pulley with an object Q hanging freely from its other end. Question 1. Why is the tension the same throughout the string? String is light, therefore tension is the same throughout the string. Part 2 is calculate the force in the wrong rod, stating whether it is tension or thrust. So what we have is object P feels tension from the string, from the pulley, pulling it up. It feels its own, P, it also feels its own weight, which is going to be 20g. Now normally also Q, if we look at Q, it feels the tension pulling you up as well. 15g, the weight pulling it down. Now because 20g is heavier, we would expect it to fall down. But because it's not falling down, we're expecting a force that is pushing it up. Because it's not falling, it would have either fallen, because 20 kg is heavier than 15 kg, it would have fallen down, but it's not, which means there is a force pushing it up, and that's what we need to calculate. The first thing is, we know that this system is in equilibrium, which means it's not moving. So it's at rest, so that means Newton's second law applied vertically to Q. That means tension 1 must be equal to 15g, which works out to be implies that T1 is equal to 147 newtons. Okay, but we want to work out this force F, which is obviously pushing up. So Newton's second law applied vertically to P, then that means T1, which is equal to 147 newtons, must be equal to 147 Newton plus, so forces acting up must be equal to forces acting down. So 147 plus F must be equal to 20 G, which means F must be equal to 20 G take away 147, which works out to be 49 newtons. So 49 newtons, F is equal to 49 newtons acting upwards. Therefore, F must be equal to 49 newtons thrust. Because normally tension works away from this. If it was tension, it'd be working away from P. Like this. This would be tension. But because it's working in the opposite, we've labeled F the opposite direction, and it works out to be positive, it must be working towards it, which means it is thrust. So this was F, what we just worked out. A car of mass 900 kg tows a trailer of mass 600 kg by means of a light and rigid tow bar. So we've got a car which has weight 900 g, and then we have a trailer weight 600 g. It feels tension because there is a tow bar in between connecting it, and the car experienced a resistance of 200 newtons, so 200 going back, and trailer has a resistance of 300, so 300 this way. If the car exerts a forward force of 3,000, so we know forward force is 3,000, find the tension in the tow bar and the acceleration of the system. So A. So let's apply Newton's second law to the whole system. Newton's second law horizontally to whole system means 3,000, so accelerating forward. 3,000, so this is T, plus T minus 200 minus 300 must be equal to mass, which is equal, total mass is 1,500 kg times acceleration. The T's and the T's cancelled out. What we end up with is 2,500 is equal to 15,000 A. So A is equal to 2,500 divided by 1,500, which works out to be 5/3 meters per second squared. But we're also trying to find the tension. So we isolate one. So Newton's second law applies horizontally to the car, to C. Then we end up getting 3,000 minus 200 minus T, so forces acting forward, take away forces acting backwards, must be equal to mass, which is 900, times acceleration, which is equal to 5/3. So T must be equal to 3,000 minus 200 minus 900 times 5/3. So tension works out to be 1,300 newtons on my calculator. Okay, part B. The driver brakes and the car travels 75 meters as it slows down from 20 meters per second to 10 meters per second. What will the deceleration of the system be? So that means if I set up a Suvat equation, then we know it's traveled 75 meters. It's slowed down from 20 to 10. We're trying to work out the deceleration, so this is question mark. We don't care about the time, so we've got S, U, V, and A, which means V squared is equal to U squared plus 2AS. So 10 squared is equal to 20 squared plus 2 times A times 75, which means A will be equal to 10 squared take away 20 squared divided by 2 times 75. Acceleration is equal to, if you put that into your calculator, you get minus 2 meters per second squared. So deceleration is equal to positive, because we already said deceleration is 2 meters per second squared. That's B. Part C. Find the braking force applied by the car and also the force in the coupling as the car and the caravan decelerate. What is the name of this force? Okay, so what we do know is we've got a new diagram now, which is we've got the trailer, we've got the car, we still have tension, we've got 200 this way, resistance still, and 300 resistant here. We know is still moving forward, but decelerating at 2 meters per second, so it's -2. And we know there is a braking force which is actually acting in the opposite direction to what is traveling, so let's call this F. So that means if we do Newton's second law applied to C, so Newton's second law applied horizontally to C, then we know minus F minus T minus 200. There's too many unknowns there, so we don't do it to Newton's second law to apply Newton's second law to C. We do Newton's second law horizontally for whole system. So forces acting forward, which is only T. Subtracting the forces working to the left in the opposite direction, so minus T minus 200 minus 300 minus F must be equal to total mass, which is equal to 1500 times acceleration, which is -2. So if I do that, the T's cancel out. All I'm left with is minus F minus 500 is equal to minus 3000. So that means minus F is equal to minus 3000 plus 500 is minus 2500. So F is equal to 2500 newtons. So the braking force applied, braking force applied is 2000. So therefore, braking force is equal to 2500 newtons. So that's the first part done. The second part is also the force in the coupling as the car and the caravan decelerate. So we're trying to find the tension. So if I want to find the tension, I can do Newton's second law applied horizontally to the trailer. Then that means forces acting forward is T minus forces acting backwards is 300 must be equal to mass, which is equal to 600 times acceleration, which is -2. So T must be equal to 600 times -2 plus 300, which means T is equal to minus 900. So because tension is minus 900, it must be, it was labeled incorrectly, it must be thrust. So it's actually acting in the opposite direction. This is thrust. So therefore, T is equal to 900 newtons thrust, because it's acting in the opposite direction that tension normally works at. Okay, next question. Figure 5 shows two boxes, A of mass 12 kg and B of mass 6 kg sliding in a straight line on a rough horizontal plane. The boxes are connected by a light rigid rod which is parallel to the line of motion. The only forces acting on the boxes in the line of motion are those due to the rod and the constant force of F newtons on each box. So they've drawn everything out for us. The boxes have initial speed of 1.5 meters per second squared and come to rest after sliding a distance of 0.375 meters. Calculate the deceleration of the boxes and the value of F. So part 1 is set up a suvat. So we know it's traveled 0.375 meters. We know the initial speed is 1.5. We know the final speed is, it comes to rest, so it must be 0. Acceleration is what we're trying to find. We don't know the time. So we've got S, U, V, and A, which means V squared is equal to U squared plus 2AS. 0 squared is equal to 1.5 squared, 2 times plus 2 times A times 0.375. If I rearrange, A is equal to negative 1.5 squared divided by 2 times 0.375, which means A is equal to -3 meters per second squared. So therefore, deceleration, because that's what they wanted us to work out, is equal to positive 3. So we were saying deceleration. So it's equal to 3 meters per second squared. Find the value of F. So if I work out Newton's second law horizontally for a whole system, then I know -2, because there's nothing obviously acting forward, or the only forces acting are acting in the opposite direction to motion. So it's going to be negative F minus F, which is minus 2F, must be equal to total mass, which is equal to 18, times the acceleration, which we just worked out is -3. 18 times -3. So which means F is equal to 18 times -3 divided by -2, which implies F is equal to 27 newtons. Part 2, calculate the magnitude of the force in the rod and state with reason whether it is tension or a thrust. Comprehension. Okay, so if we just label it as tension, then if we apply Newton's second law horizontally to B, then what we do know is there's no forces acting forward, only 2 forces acting back. So negative F minus F minus T is equal to mass, which is 6 times acceleration, which is -3, which means if everything's negative here, if I change everything to positive, F plus T must be equal to 18. F is equal to 27, don't forget. So 27 plus T is equal to 18. So T is equal to 18 minus 27. T is equal to -9 newtons. Okay, which means T is not actually acting this way. So T must be equal to, because it's acting towards the, so actually T is actually acting towards the each box, which means it's thrust instead. So it's thrust. So therefore, magnitude of force in the rod is equal to 9 newtons thrust as the force is acting towards each box. So it's not pushing, it's not pulling, it's pushing. Pushing into each box.